Hi, I'm Steve Wireman, and today I'm going to talk about logic and control structures. This is the fourth video in a series on getting started programming with Java. For more information, visit my website, www.iteran.com. So, we talked a little bit about the various data types in Java, the primitive data types, and one of them is Boolean. And I told you that Boolean is a true or false value. Well, true or false values, Boolean values can be operated on, just like mathematical values can be operated on. We've got three basic Boolean operators. Two of them are binary operators, so they take two Boolean values and they return a Boolean value. And, for instance, we'll return true if both the Boolean values that we're sending to it are both true. Or we'll return true if at least one of those values are true. Otherwise, or returns false. And returns false if at least one of those values is false. Not is a unary operator. It takes one Boolean value and it just flips it. So not true is false and not false is true. We'll see some examples of this in a moment. We also have comparison operators. So for numeric values, we can compare them, and it works just like you would expect. We have less than, greater than, less than equal to, greater than equal to. This double equal to operator is how we do comparison, because remember, the single equal to operator is for assignment. So if you're comparing two values and you want to make sure they have the same value, you need to put two equal signs. And then we have the exclamation mark equals to that's not equals to. So here's an example of an if statement. So if x double equals 42, then we just print out 42. So this line of code here will only execute if the value stored in x is 42. Otherwise, it doesn't execute. Here's an example of an if-else statement. So again, this line of code will only execute if x equals 42. And then we have our else statement, and the else statement only executes if x does not equal 42. And it's pretty straightforward. It's exactly what you'd expect. Then we can join else's with ifs. So here's a simple example. If x is less than 10, then we're going to do these two things. And the way we indicate that we're going to be doing more than one line of code for that condition is that we put those lines of code inside of curly braces. So typical Java coding convention is that even if you only have one line of code, you're going to still use those curly braces because it's just good form. And if you have to do something more, if you decide you need to change your code later and you want to add more things that you need to do, if that condition is true, then you just throw in those lines of code and you don't have to go back and add in the curly braces. So just get in the habit of, if you're writing an if statement or any of the other control structures that we're going to look at in a moment, if you're using those, use curly braces even if the result is only one statement. So let's look at this example. If x is less than 10, we'll print out that x is too small, and we'll add 10 to x. If, this is else if, I'm sorry, if x, ooh, there's a bug there. That should be if x is greater than 30. So switch that around. If x is greater than 30, then print out x is too big, and subtract 1 from x. Else, so again, this is if x is not less than 10 or not greater than 30, then we're going to do this. X is okay. So this will detect if x is between the values of 10 and 30, and if it is, we don't change it. If it's greater than 30, we're going to subtract 1. If it's less than 10, we're going to add 10. Now you may remember from the last video, I told you a few shortcuts for doing mathematical operations where you're just changing a value. So we're doing an operation on x, we're changing the value in x by adding 10 to it. If you remember the shortcut, it's plus equals. And the same thing here, we're just subtracting 1, we're decrementing x by 1. If you remember the shortcut, it's double minus. So you can see that there. And again, this should be x is greater than 30, not x is less than 30. We also have what are called switch statements. Now, switch statements you can think of as a more organized way of writing if-else statements. There's some nuances that you got to be careful about with switch statements. But ultimately, what you're doing here is you're taking a value, you're looking at this value that's in x, whatever this is, and if you find a case that matches that, so in this case, if x is 1, then we're going to print out x equals 1. And this break is important because in a switch statement, if you don't have that break, it's not like the if-else thing. If you don't have that break, then it's going to execute everything below that until it reaches the end of the block or until it reaches a break. So for most switch statement cases, you're going to want a break after each case. So if x is 1, we print out x equals 1. If x is 2, we print out x equals 2. And then we have this default. This is like our final else. If x is not 1 or 2, we're going to execute the code in default. And that is x equals something else. We just print that out. We also have for loops. Loops are ways of executing the same code with different, well, probably, hopefully different values, because if they're not different values, then we end up in an infinite loop. So a for loop has some, that was weird, initialization, some condition, and then a step. That's very strange. I don't know why my slide is doing that. So I just can't highlight these things. So we have an initialization, a condition, and a step. So we assign a value to something. So in this example, we initialize, we declare, and assign I the value 0. And so long as I is less than 100, we're going to execute the code that's in these blocks, whatever that is. And our step size is 1. So after we finish that first execution of that for loop, we're going to add 1 to I, and then we're going to execute whatever's in that block again. And then we just keep doing that until this condition, this I is less than 100, is no longer true. So this whole thing here will run whatever code's in that block 100 times. We also have while loops. Now while loops are similar to, they're loops, they're similar to for loops. We have some condition. Now this is just some Boolean expression. So while, in this case, x is less than 30, we're going to do something. And hopefully what we're doing in here is going to change the value of x to the point where x will at some point be greater than or equal to 30. Because if it's not, again, we'll end up in a infinite loop. And we don't want that. We also have do-while loops. And the only difference between a while loop and a do-while loop is that a while loop is what's called top-tested, and a do-while loop is bottom-tested. So, for instance, suppose x is already greater than or equal to 30. If x, let's say x is 30, once we hit this line of code, we're not going to execute what's in here because this test evaluated to false, so we don't want to do what's in this block. A do-while loop is a little bit different because once we hit this do, we're going to do this at least once. And after we do that, we test while x is less than 30. If x is less than 30, we're not going to do it again. So the difference between while and do-while loops execute always at least once, whereas while loops might not execute at all, depending on if our test evaluates to true or not. So 3 words of caution about control structures in Java. First, float and double. If you're using a floating point value, you want to be very careful if you're doing equals comparison. If you do that double equals for a float value. The reason being is when you're working with floating point arithmetic in computers, you may have rounding errors, minor rounding errors. So if you have something that you want to check to see if it's equal to 2.3, if the value stored in x is 2.30000001, those comparisons are not going to evaluate true, even though you might want it to. So typically, you're not going to want to use is equal to for floating point or double values. Instead, you might want to specify some range of values. So if you want it, if you're trying to get to 2.3 and you know it needs to be between 2.301 and 2.299, you can do that comparison instead, and then join those two comparisons with an AND. Strings. In Java, you do not want to use double equals for strings. The reason being is strings are objects, and objects in Java have an equals method. So you want to use that method, and we'll talk more about the equals method in a later lecture, but you'll want to use that method to compare two strings in Java. If you're doing the double equals, what you're actually doing is comparing the two instances of an object rather than the actual values they hold. Because when you create an object and you create another object, and you're trying to compare the two, you're probably interested in whether or not those two objects hold the same value, and not whether or not they actually are the same object stored in memory. And we'll talk more about that when we revisit classes and objects later in the series. And then the third word of caution is brackets. Like I said, you want to make sure that all your code for conditionals, for loops, all those are inside brackets. You don't want to leave off those brackets, even if you're using this, just doing a single line of or single statement for your conditional. So now that I've rambled on about those things, let's see an example of this. So for our example, we'll just revisit our payroll example. And what I'd like to do with this is change it so that if the number of hours worked per week is greater than 40, let's calculate the overtime pay. So the way it works is, in the US anyway, individuals who are employed typically are paid time and half, or time plus half that time, for overtime work, or they're paid at a rate 1.5 times what they would be paid. So the first 40 hours they get paid at the regular rate, and then anything beyond that they get paid at the time and a half rate. So the way we'll do this is we'll put in an if statement here right after we print out number of weeks, right before we calculate the pay amount. So if hours worked per week is greater than 40, then we've got to figure out how many hours more than 40 they worked, figure out how much they should get paid for that, and then figure out how much they should get paid for 40 hours. So they should be paid, let's do it this way, pay amount equals hourly rate times 40 plus hourly rate times 1.5 times, and then the hours beyond 40 that they've worked. So that would be hours worked per week. Maximize this so you can actually see what I'm typing. Minus 40. So that should do it. Let's change this to else. If they haven't worked more than 40 hours a week, then we'll just calculate the pay rate as normal. And then to make sure this works, let's say that they worked 45 hours. And let's hit run. So there's our new pay amount, and you'll see the amount is actually a fraction of has a fraction of a cent. So typically with money, you're not going to want to use double value or float value. You'll want to use an integer, and that's another thing we'll revisit at a later date. So I hope you found this useful, and check back tomorrow for the next video.